I wanted to jump right into this video, assuming that you've already seen the first part. So here are some more experiments and scenarios to think critically about. This model is in opposition to relativity's interpretation of how an observer would witness the same scenarios. But no need for mental gymnastics or millions of dollars of Hollywood CGI. You could work this out using software like Blender, or just visualize it in your mind's eye, as long as you don't have aphantasia. So, to reiterate the main point, we are not looking back in time when we see galaxies and stars and distant locations. Light is not a recording of reality that replays the history of an event from that location. Reality is not broadcast. Reality does not dilate. Time is not relative as Einstein suggested. The entire theory of relativity is outdated with egregious misconceptions. That model is based upon the framework of Lorentz transformations. But we will be interpreting time and reality under the framework of Galilean transformations instead, as they were reformulated by Dr. Edward Dowdy in 1991. Every experiment and observation and test attributed to relativity can be reinterpreted to dismantle relativity. Every single one. So let's begin with some hypothetical scenarios of how we can view light, time, and reality. But first, we have to talk about how light propagates, and what is a wave front and what is a wave end. So we'll start by showing a simple analogy of water coming out of a hose. The point where the water first starts coming out of the hose is the front part of the wave front. And the point where the water stops coming out of the nozzle is the wave end, where it ceases. But take note that the water that already left the hose, it will continue to propagate out, even if the hose is turned off or is destroyed. And if the hose or the nozzle itself is traveling, then you have to account for that speed, in addition to the speed at which the water is coming out of the nozzle. So imagine the hose as a laser pointer, and the water shooting out is light traveling at light speed. So if the hose or the laser pointer is moving in a particular direction, then you have to account for that and add that on top of the speed of light. Because the water is coming out at the same speed, the light is always coming out at the same speed, but if the source is moving, then you have to add that velocity on top of the light. So that means that the velocity of light is indeed dependent upon the velocity of the light source. But there's an illusion, and this alternative to the invariance of the wave equation, derived by Dr. Edward Dowdy, exposes that illusion. Einstein thought the velocity of light is the same to everyone in all frames of reference, because whenever an observer measures, that's all that you can detect, is the light re-emitted from the electrons making up yourself. And since that light is traveling relative to the electrons making up yourself, it serves the illusion that the velocity is the same in all frames. But that primary light could be coming in at a faster velocity or slower velocity, depending if that source is receding away from you or coming towards you. And the light coming from that particular source, you can never tell what velocity it is traveling at, because the electrons making up the observer will absorb that incoming primary and re-emit a brand new secondary. So here's another quick example. All the light you ever see is the re-emitted light from the electrons making up yourself. It is never the same light coming from a flashlight into your eyes. It's never the same light bouncing off of a mirror. It's never the same light passing through water or a lens or refracting. It's always a brand new light at every point of interference. So the light coming out of the flashlight is propagating at the rate of c. And then the electrons making up the surface of the mirror absorbs that incoming primary, which diminishes to zero, and as an equal and opposite reaction, a secondary re-emission is re-emitted from those same electrons, and that is traveling relative to the surface of the mirror. And then the electrons making up your eye will absorb that again, and a third wave packet will be re-emitted into the rods and cones of your eye, which you will detect and measure that. And if the flashlight is moving towards the mirror, then the light coming from that particular flashlight is traveling c plus the velocity of the flashlight. But by the time the light actually hits the mirror, the electrons making up the mirror will absorb it and re-emit it from its own frame of reference at the velocity of light c again, and then into your eye. So by the time any light ever reaches your eye or a sensor or detector, it will be re-emitted as the frequency of interference between the source and the target, and you will never be able to measure the velocity of that primary. But you can see a flash before one source or another. So all of that was just so you can be able to have context to understand these next hypothetical scenarios and experiments where a person could see one light faster than another light. You might not be able to measure the exact velocity of an incoming primary, but one observer can see a flash before another. But this would have to be over a very long distance, and you would have to zoom out far enough so that you can see a beam of light or a packet of light long enough so that it can have a delay between 2 points. And then you can see a definitive wave front and wave end, almost like a phaser from Star Wars or Star Trek when they fire a pulse from the blaster weapon. But instead of that just being a short pulse, imagine that being an emission from a star lasting millions of years. So the distance that the packet reaches could be millions or billions of light years. So I just want to have the analogy of treating a pulse of light like a shock wave that travels out from a source, and that shock wave lasts for a long time at a constant, but there is a definitive front and back to that shock wave. So whether it be a collimated beam from a laser or a spherical emission from a star or a light bulb, the point is that when the source is cut off, you have a definitive wave end. But the shock wave and light and gravity that leaves a star will continue to propagate out even if the star blinks off, blows up, fizzles out, or is destroyed. One other point before moving on is that the scientific community lost its way, confusing the difference between evidence versus proof. I think we need to get back to the basics and make a clear distinction between evidence and proof. Proof is simply a mathematical equation to show how you arrived at the solution of a derivation. Evidence is collected through experimentation and observation. So you could point a flashlight or a laser beam at a mirror and conduct 10,000 experiments, but those experiments will never provide proof and math for you. It provides evidence, and you can interpret that evidence using a mathematical framework of Lorentz transformations or Galilean transformations. Lorentz transformations and relativity prove that it's the same light bouncing back within the same frame of reference and continuing on. But Galilean transformations mathematically prove that it's a brand new secondary light at each point of interference, and depending upon the source is moving away or not, will determine the velocity, but the illusion is that the electrons making up any target will absorb that and re-emit a secondary relative to itself. But there are no experiments to conclude whether it's the same light or a brand new light. That is in the interpretation using a given mathematical framework, and you are subject to the consequences of that mathematical framework that you use. But the world has been stuck on relativity in thinking that math is the end-all, be-all validator to a scenario, and that is the only mathematical route to yield the correct predictions and solutions. But Galilean transformations, as reformulated by Dr. Dowdy, can also yield the same predictions and solutions, but by reinterpreting the entirety of the scenario differently with the same end result. The light comes in at an angle of incidence and is re-emitted at a tangent, but it's a brand new light, not a same light, and it's a different frame of reference. So when you see article after article claiming our experiments have proved relativity and proved ourselves right again, you know it's just nonsense and an echo chamber of junk science and an idiocracy of nepotism where people are just repeating their experiments and their claims under one mathematical framework. So the entire point of science itself is to be able to yield the correct predictions and solutions of a given scenario, but in the simplest method possible, a la Occam's razor. But the scientific community doesn't do that anymore. They try to reap grant money by continuing their actions expecting different results and then dismissing anybody with a credible challenge to say that they are a crackpot or it's pseudoscience. But indeed, there are experiments that we can conduct which will show a stark contrast and discrepancy between relativity and reality. Whew. All right. Had to give you some background so that you can understand the rest of the scenarios. But just imagine how difficult it's been for me to try to communicate all of this through text. So, who would see a flash of light first? Observer A on the left or observer B on the right? First, let me detail the scenario a bit more. The two observers are standing back to back. There are two laser pointers, both a fixed distance from each observer, 1 light minute away. The blue laser is 1 light minute away from observer 1 or observer A, and the red laser pointer is 1 light minute away from observer 2 or observer B. The laser pointers are stationary relative to the observers, so their velocity is 0. Both of the laser pointers are started at the same time, the same distance from each observer. So who sees the flash of light first? Observer A, B, or both at the same time? In this scenario, because the laser pointers are stationary relative to them, both of the observers will see a flash of light at the same time. If it's 12 noon when the laser pointers are turned on and they're 1 light minute away, then both of the observers will see a flash of light at 12:01. But take note that neither observer will see the moment that the lasers were turned on. You're not looking back in time 1 minute in the past just because it takes light 1 minute to reach the observers. They'll simply see a flash of light 1 minute after the lasers were turned on. The light that already left the lasers will make it to the observers even if the laser pointers are turned off or if they're destroyed. It's just that the observers will see a flash of light from the general direction of where the laser pointers were 1 minute before. So the history of the event is not contained within the packet of light. Light is not a recording of reality. A photon is not a packet of reality. The light sent out by those laser pointers will just illuminate reality as it is in real time with red light or blue light. Okay. So we started with the first scenario of the stationary laser pointers, and both observers saw the flash at the same time because the laser pointers were a fixed distance away, 1 light minute away from the observers, and both laser pointers were turned on at the same time. But now we're going to see the second scenario where the red laser pointer is moving at half of the light speed towards the other observer. So like a bullet from a gun that is on a train and the water from a hose that is moving, you also have to account for the speed at which the laser pointer is moving towards the observer. So imagine that the red laser pointer is moving towards the observer at half the speed of light. Both laser pointers still blink on at exactly 1 light minute away from each observer, but the red laser pointer is moving towards its observer at half light speed. And again, just like the water that leaves the hose, or the bullet that leaves the gun, the light that already left the laser pointer will continue to propagate out even if the laser pointer is turned off or destroyed. And the light coming from that particular source will be traveling at the velocity relative to that source. So the second observer will see a red flash before the first observer sees the blue flash in this scenario. Let's say the length of that wave packet stretches to be 1,000,000 light years. And the observer is 1,000,000 light years away. So it'll take 1,000,000 years before the observer sees that initial flash of light. But what happens if the observer starts looking after the initial wavefront passed him long ago? A source can put out a fast radio burst or could put out some light, and then that source could be extinguished by the time that light even reaches us. So we'll look out at that location and then see a flash of light or get some burst and then attribute it to something that isn't even there. One thing I really want to drive home is that neither observer is going to see back in time 1 minute just because the laser light took 1 minute to reach them from that distance away. Light is not a recording of reality. We are not looking back in time when we see galaxies and stars. Under Lorentz transformations and relativity, the velocity of light is the same in all frames of reference no matter what, and time shifts. But in classical physics, it's the opposite. Time remains constant in all frames of reference no matter what, but the velocity of light shifts depending upon the velocity of the light source and then the illusion of the electrons absorbing and re-emitting. But under this model, we're forced to deal with the consequences under Galilean transformations instead. And that says that time is constant no matter what. But according to relativity, we are looking back in time equal to the distance it takes light to travel. So, according to relativity, we're looking back in time 1.25 seconds when we see the moon. We're looking back in time 3 minutes when we see Mars, 8.33 minutes when we see the sun, and we're looking back in time 1,000,000 years in the past if something is 1,000,000 light years away. But under this model, we are not looking back in time 8 minutes when we see the sun. We're not looking back in time 3 minutes when we see Mars. Yet, the signals and light that comes from the sun indeed propagates at the velocity of c and has a delay. But that's not a recording of reality. Just as the shock wave from a volcanic eruption does not allow you to see or hear back in time, it's just that the wavefront of that shock wave has a delay before it reaches you. Imagine a volcanic eruption that produced a sonic boom. You're not hearing back in time equal to the distance it takes sound to travel. If it takes 10 seconds before the shock wave of the sonic boom hits you, that shock wave is not allowing you to hear back in time 10 seconds. Now imagine the Marvel character, the Daredevil. The Daredevil sees using sound, like a bat. If that delayed shock wave took 10 seconds to reach the Daredevil, that sonic boom would simply illuminate the surroundings and Daredevil could see what's going on in real time. The same applies to all light that leaves any distant source. It might take a delay before that packet reaches you, but you're not looking back in time just because it took a delay for the property of illumination to reach you from that particular source. It's just that you'd be able to see reality in real time, regardless of distance. The history of the volcanic eruption is not recorded or contained within that delayed shock wave, just as the history of reality or the history of an event does not unfold or replay as if the light itself is a recording of reality. Light simply illuminates reality as it is in real time. But the properties of illumination from a given packet might have a delay before you see a flash of light from the initial wavefront hitting you. Then you'll see reality illuminated in real time for however long that light is on. And then the back end of that wave packet will appear like a wall of darkness approaching at the velocity of c. Then that particular packet of light from that distant source will just blink out and cease. Visible light in the terahertz range is electromagnetic radiation. All electromagnetic radiation propagates at the velocity of c relative to the source that it comes from. Whether it be a bullet from a gun, water from a hose, or light from an emitter, the emission travels relative to the source. Microwaves, infrared, visible spectrum, X-rays, gamma rays, it's all light. But we're not looking back in time equal to the distance it takes a given electromagnetic radiation to propagate. It's just that you'll be able to observe reality as it is in real time after the wavefront of that particular wavelength finally reaches you. If a star is 10 light minutes away and puts out a burst of X-ray, it'll take 10 minutes before that X-ray packet spherically expands from its source and reaches you to illuminate reality in real time. If you had X-ray vision, you would see a flash of X-ray light after 10 minutes, but you wouldn't be looking back in time within the X-ray spectra. It's just that you would be observing reality in real time, and once that X-ray packet finally reached you, that overlapping wavelength would then illuminate reality with an additional wavelength. So let's follow through a scenario where we're watching a SpaceX rocket leave Earth and just continue on to Mars. But we're watching the entire trip through a telescope. And this magical telescope that doesn't exist has a variable focal length, meaning it's able to just continually watch the astronaut all the way until he lands on the surface of Mars, keeping the astronaut the same size in the telescope the entire trip as he moves farther and farther to 3 light minutes away on Mars. You'll just be looking at the astronaut in real time through the telescope. So really, if you wanted to see a 6-foot-tall person standing on the surface of Mars, it would require a telescope 11.3 miles in diameter. So what I'm claiming is that if you were to have a telescope that large and able to see an astronaut standing on the surface of Mars, you would not be looking back in time 3 minutes. You would be looking at them in real time. But any new radio transmissions or new emissions of light coming from Mars, those will take 3 minutes with a delay to reach the observers watching through a telescope from Earth. Now, we can hold up a sign, yes or no, and you can see that through the telescope in real time from Earth. But if I flick a lighter from the surface of Mars, you won't see that flame unless my finger is still on the button for 3 minutes, the full 3 minutes that it takes that wavefront to reach you. Then it will just be as if you were able to see the flame the whole time. Not that you're looking back in time 3 minutes just because it takes light 3 minutes to propagate from Mars to Earth. It's just that the properties of illumination from that particular new wave packet will have a delay of 3 minutes by the time it reaches you. But take note that all points in space are already illuminated by existing starlight. So any new incoming wavefronts from distant sources will just overlap the existing light that's already illuminating reality. So if you're looking at an astronaut on the surface of Mars through the telescope and he's holding up a sign and flicking a lighter at the same time while sending a radio transmission, you're going to see the sign in real time, but it will take 3 minutes before you see a flash of light, and it will take 3 minutes before you receive that radio transmission. And if you judge reality itself by the delay of the radio transmission or the delay of light, and you think that light itself is a recording of reality, then you're going to have major misconceptions. So if we had a telescope that large, it would expose an unreconcilable discrepancy of relativity. But part of the main point of this entire dialogue is to express the notion that we are not looking back in time and that light is not a recording of reality. It is impossible to determine the age of the universe or a celestial body from observation alone, because everything that we are seeing is happening right now in real time with no delay of reality. Regardless of distance, time is not connected to space or velocity or acceleration or gravity or size or distance. None of that. It is independent of all of that. Time is a constant, but the velocity of light shifts in different frames of reference. Einstein had it backwards. Relativity should be abandoned. And Dr. Edward Dowdy's model should be adopted. Before I can answer these questions, I have to address some misnomers that relativity has popularized due to using Lorentz transformations. The use of Lorentz transformations is a mathematical artifice that indeed can yield the correct predictions and solutions and end results, but does so by misinterpreting the entirety of the scenario and inventing variables that don't exist. So, relativity says you can't travel faster than the speed of light because it would require more energy than available in the universe, and your mass would grow in proportion to the velocity and acceleration up to light speed. But effective mass is the mathematical equivalent of relativistic mass under Galilean transformations. There is no length contraction or time dilation under Galilean transformations. There is also no requirement for any media to propagate light or gravity. There is no fourth dimension and no ether in this model. And also, there is a difference between the velocity of light constant and the constancy of the velocity of light in all frames of reference. So what that means is that since there is no light speed limit, mass does not increase with acceleration, and there is no requirement for any medium, that means the entire concept of Alcubierre drive is a fallacy. There is nothing to warp. But I do think Star Trek, Star Wars, and the Jetsons got this part correct, that, like the Starship Enterprise, can zip off into space many times faster than the speed of light using their alleged warp drive, with absolutely no dilation of time or reality between any civilizations that they encounter. So if you travel faster than the speed of light, you'll simply arrive at your destination faster, and you'll see your destination approaching you faster. That's it. But the faster you go, the more flashes of light that you might see in different wavelengths, given that you'll be running into the wavefront of various wave packets that would not have reached you unless you were traveling that fast towards those sources. But if you were traveling away from those sources while looking forward, you would see flashes of light and then those sources blip out, because you would be outrunning those wavefronts again. Likewise, if an astronaut is standing on the surface of Mars and flicks a lighter, and you're starting at Earth, hopping in a UFO, and traveling at light speed towards the astronaut, it's going to take 1.5 minutes before you see that flash of light from the lighter. And if it normally takes light 3 minutes to propagate from Mars to Earth, and you hop in a UFO and travel away from Mars while facing that astronaut looking through a telescope, but you're traveling half light speed away from that source, the astronaut will flick the lighter, and it will take 4 minutes and 30 seconds before you see that flash from that particular source. So let's say you flick a lighter on Earth, and then you hop in a UFO, and you travel away from Earth faster than the speed of light to outrun that wavefront produced by that flick of the lighter. So you go faster than that, and then you turn around, and you look through a telescope back at where you just flicked the lighter from. What would you see? You just see a flash of light once that wavefront finally reached you. You're not looking back in time. You're not going to see a hologram match up and sync up to where you are. None of that Hollywood fantasy. You're just going to be looking back from where you came from, and you'll see a flash of light from the packet because you outran it. But that light does not contain the history of you flicking the lighter. It's not a recording of reality. It's just like a shock wave, and the boundary of that packet will illuminate reality once it catches up to you. You could travel hundreds of quadrillions of times faster than light, given you have the energy to do so, and there'd be no dilation of reality at all. You just have to worry about running into something with more mass than you. Smaller masses would not matter since they would be repelled away from you at those velocities. But there is no curving of space-time or warping reality or dilating reality or any of that. You can interpret the scenario as if all of that is taking place, but it is not literal. It's not real. Relativity is like the common core of physics. It describes scenarios as if they were real. So people need to shy away from what ifs and what should be and accept what is. The world does not revolve around your ego. The universe does not revolve around Earth, and the interpretation of the universe does not revolve around relativity. We must remember that science is not a consensus or made of a hierarchy or board members that determines what is right or wrong. Einstein himself said that if there were any other methods that could yield the same predictions and solutions as relativity at any time in the future, that relativity would not be needed and would eventually collapse. And that lasted for 100 years until 1991 with the work of Dr. Edward Dowdy. So now I'm going to add this segment about this hypothetical scenario that was included in the original video. And then that will give context to talk about gravitational shadows. There is a planet situated in between three equidistant stars, 10 light minutes away from each other. Each of the three stars is producing a monochromatic light, a red light, a blue light, and a green light. We can imagine the stars pulsing on and off like a light switch. Each colored star will remain on for a given amount of time to produce a color wheel effect for an observer on the planet 10 light minutes away. The observer is not looking back in time 10 minutes just because it takes light 10 minutes to propagate from each star to the planet, but rather the observer would view all locations in real time without any delay of reality, while the color shifts for the observer, and there's a delay for each color shift by 10 minutes. But again, the observer is not looking back in time. The observer just sees reality as it is, but with a delay in shifting colors. Wanting help from graphic designers so that I could animate these depictions, I set up this central planet and three equidistant lights, and then turned on and off the different combinations of colors so that we can see the shifting of those colors as an observer from that central planet. And we can see the different colored shadows that the different colored lights make. Blue light produces a yellow shadow. Green light produces a magenta shadow. And the red light produces a cyan shadow. Then you start to have combinations and then all three. You can see the cyan, yellow, magenta, and then when those intersect, we get the red, blue, and on the other side, let's see the green. Just as light illuminates reality, and doesn't matter what wavelength, it could be from a monochromatic star like a red star, green star, or blue star, the light itself illuminates reality as it is in real time. The consequences of this model show that light and gravity behave the same. All the light you ever see is ultimately the re-emitted light from the electrons making up yourself. And I think the same applies to gravity. All the gravity we ever feel is ultimately the re-emitted gravity from the electrons making up ourselves. And the illusion is that we can only measure the re-emitted gravity from the electrons making up ourselves, so it's physically impossible to measure the primary gravity from any source or to measure any gravitons, because the gravity is re-emitted as a secondary from the frame of reference of the electrons making up Earth and the electrons making up everything on the Earth. So it's my personal belief that, according to the consequences of this theory, that light and gravity behave the same and that there are probably gravitational shadows. I think that gravity has a spectrum just like light. And just as different light can have different colored shadows, and given that a colored light can have a given colored counterpart shadow, it doesn't matter the color of the shadow or the color of the light. Light still illuminates reality regardless. A primary gravity, a re-emission of a secondary gravity, or a gravitational shadow will affect surrounding bodies regardless. Have to give a little background for context on why gravity does not affect light whatsoever. The scientific community treats the corona and photosphere of the sun as a vacuum, so they attribute the deflection of light to gravity. But there is clearly condensed matter present in the form of metallic hydrogen in the photosphere and corona, which means the deflection of light at that location can be explained through refraction. There is no deflection of light above 1 solar radii. The same equation for relativity bending light is the same equation for 3D optics under Fermat. But that equation, again, only applies at 1 solar radii. Relativity invents a bunch of other equations to suggest how light should bend a given distance away at 2 solar radii or 3 solar radii, but that has never been observed. Gravity drops off according to the inverse square, but light does not deflect according to the inverse square. Luminosity drops off according to the inverse square, but light only deflects according to 3D optics under Fermat via refraction. If there's no condensed matter or plasma present, then there's no deflection of light. This detailed source with references and citations that I posted on my Twitter or X thread goes into great detail on this. So the alleged gravitational lensing due to distant galaxies is different than the alleged gravitational lensing produced by the sun. This page and this image addresses that specifically here. That is data processing errors from amplifying light by over a factor of 1,000 times brighter than it naturally is in space, which then produces forward light scatter and optical distortions just in that specific wavelength due to flaws of the satellite itself, from the amplification and data processing. But according to general relativity, those optical distortions, streaks, and arcs should be seen equally throughout the entire spectra and all wavelengths, but they are not. The optical distortions are frequency and wavelength dependent. And again, those distortions only appear because they amplify the light by over a factor of 1,000 times. And they did something similar with the M87 ring of light, which isn't real. It's fraud from data processing noise to produce artifacts which aren't there. They amplify the noise to produce a ring or artifact that best matches their simulations of what they want to see. It's confirmation bias. The claimed image of M87 exceeds the capability of the radio-optical telescopes by over a factor of 1,250 times. So it's garbage in, garbage out. So light does not behave as they teach, gravity does not behave as they teach, and time certainly does not behave as they teach. Gravity does not affect light or time, and this has drastic consequences to the so-called twin paradox fallacy and a bunch of other relativistic concepts. Just to address that really quickly, let's say it takes 20 seconds to say a mantra, and then you have a space in between the mantra. So 21 seconds to say the mantra with a pause in between. Let's say two twins on Earth start saying the same mantra with the same timing. One of the twins hops in a spacecraft and travels faster than the speed of light for 30 years, and when they come back and meet each other on Earth, they will have said the same number of mantras with the same timing, yet their clocks will be drastically different, and one twin will look younger than the other one. And this analogy I use is like picking two apples from the same tree. One apple sits in the sun, while the other is vacuum-packed in the freezer for 30 days. So you take the one apple out of the vacuum-packed freezer and put it next to the other apple that's been in the sun for 30 days, and you see that one of them will look more decomposed than the other, even though they're the same age. There is a lot more to discuss and more information to put in context and present, but I think I'm going to leave it here because people's attention spans are going to wear out and people are going to get a headache from the amount of information already jam-packed into this presentation. So I'll just leave it here at this point, hoping that it'll at least provide graphic designers with enough context to help make more visuals to upgrade this crude video into more professional documentary. This information should get the justice and attention it deserves. I don't expect people to agree with the information, but I do expect people to understand it. So people can put this model side by side next to relativity and think critically about which is the simpler solution. This information can lead to a revolution in humanity's understanding of time, gravity, faster than light communication, refining our laws, finally acknowledging the people who have been trying to communicate these things for hundreds of years, and toss the outdated and extraneous models that are holding us back from traveling the stars as we should have been doing for the last 100 years. It's time to turn the page. Welcome to 22nd Century Science with me, Jason Verbelli. Again, there's a lot more, but thank you for giving this the time.